We're not talking about this kind of substitute. We're talking about this one. All substitutes do is replace something else. When a substitute teacher comes into the classroom, they're replacing the regular teacher. When a substitute number comes in, they replace another number. Here we have two expressions. Now, I know some of you are looking at this and saying, Mr. Melham, you said anything with an equal sign is an equation. We have an equal sign right here. Not quite. What we have here is a comma separating two different things. This here is separate. This is not part of this. This is a comma telling us that we have an expression, it's x plus 4, and I need to substitute x equals 3. I'm telling you that x is worth 3. So we're going to substitute it instead of x. So we're going to take out the x, we're going to go in there, we're going to mash them up, and we're going to put 3 instead. And then we go plus 4, and the rest of it is bedmass. So here we just have addition, we get 7. When we substitute x equals 3 into this expression, we get an equation. Because now we have an equal sign and an answer. Here we have 5v minus 5, and we have a comma, so some news is coming up. It's separate. V is equal to 3, so I need to substitute that in. So what I will do is I will go in here, I will write 5. I will substitute the v with the 3. Do you know why I put brackets? Because I have to multiply them. And remember, from now on, we are not going to use the multiplication sign. We are not doing this anymore. This is old-fashioned. This is for little kids. We're not little kids anymore. We have 5 times 3 minus 5, and we have to get an answer. We have to use bedmass. We have to multiply first. That makes 15 minus 5 equals 10. We took an expression, we turned it into an equation with an answer. Here we have a slightly longer expression. And we are going to substitute x equals 3 into this expression. So we'll just write it out the same way, the way that it looks. We'll put 3 as the substitute. We'll go minus 7, put the bracket, and go add 2. Now we have to use bedmass. Bedmass says use brackets first. 3 minus 7 is negative 4. 4 goes on the outside. We have plus 2. Now we have this. And what does this state? It states that we have to multiply and then add. So we have 4 times negative 4 is negative 16. Put it in brackets, add 2 more, and we get negative 14. That's our final answer when we substitute x equals 3. Now here it's a slightly different one. We are substituting two things. We're substituting x equals 3 and y equals 3 because we have two different variables. We call these variables these letters. We have two variables. X is 3, so we'll put 3 in. Y is also 3. They are both 3. And that makes 6. We have to turn these into expressions and then substitute the number 6. So we have 3 more than twice a number. 3 more than what? What is this talking about? 3 more than twice a number. You know what 3 more means. It means plus 3. You know what twice a number means. It means 2x. Or the letter of your choice. We're going to combine these. We could say plus 3 plus 2x. Because this is a positive 2x. Or we can flip them around. I like to flip them around. I like to put the variable, the one with the letter, I like to put it first. So I like to say 2x plus 3. I'll just flip them around. Take these and flip them. And now we can substitute. So we can put 2, put in brackets 6 plus 3. And if we use bedmass, we're going to get 12 here. Plus 3 more is going to be 15. Not too hard. Let's move on to the second one. The product of a number, the product, that means times, of a number and 7, the product of a number and 7, okay, so that's 7x. Here's the number, here's the 7, they're being multiplied. And 7 subtracted from 50. That's tricky wording. Subtracted from 50. The 50 comes first? Yes. So we're going to put 50 minus 7x. If you write 7x minus 50, that would be Incorrect. Because here we have 50 subtracted from 7x. Here we have 7x subtracted from 50. That's kind of how you gotta read subtraction equations. They're a little bit different. They're kind of kooky. We're gonna put 50. We're gonna go minus 7 and put in brackets 6. Because it says 6. So we have 50 minus, we've got to multiply first. So this is 42, and 50 minus 42 is 8. 1/3 of 6 times a number. 1/3 of 1/3. Oh, okay. 1/3 is just 1/3 of. Okay, that's not a problem. Times 6 times the number is 6x. Now we substitute. So we're gonna go 1/3. We're gonna times. Oh, Mr. Malcolm said not to use the times anymore. Okay, so we'll just put brackets. Times 6 times 6, because x is 6, right? I'm going to substitute it. Now we have 1/3. So what does this make? This makes 1/3 times 36. So I can go 36. And 36 times 1/3 is what? Top times top, bottom times bottom. I get 36 over 3, and that makes 12. All that makes 12. Now we have the perimeter equation. This is the equation to find perimeter. And it says that we need to substitute. The rectangle has a length, which is L, is 10 centimeters. The length is 10. Could we not substitute that in? We're going to put P equals 2 times 10 plus 2 times what's W's value? 5. So we're going to put 5 here. Now we're just going to use bed mass. We're going to go, this is 20 plus this is 10. Always multiply first, right? Now we're going to go 20 plus 10 equals 30, and the perimeter is 30 centimeters. The last one, we have to design our own equation here. The cost of going to the fair is $5 to get in. You got to pay $5 just to get in. Even if you don't play. Even if you just walk in and do nothing and just stand in the middle of that fair, you still got to pay that $5. But then anything extra is going to be $2 per ride for each ride. So if you go on 3 rides, isn't it going to be 2 times 3? If you go on 8 rides, isn't it going to be 2 times 8? Do I know how many rides I'm going on? We do. It says right here 9 rides. But assuming I don't know how many rides, it says set up the equation, which means don't read this bottom part. Yeah, that should be B. Don't read this bottom one yet. Just set up the equation. So we're going to say the cost. That's the cost of going to the fair is, the cost is $5. You got to pay it. Everybody's got to pay $5. And, so plus, and $2 for each ride. $2 for each ride. So 2R, 2 times R. Okay, that's all it is. 2 times R. If you go on 6 rides, you're going to go 2 times 6. Whatever R is, you have to times it by 2. You got to double it. What is the cost of going on 9 rides? Let's substitute. So we're going to write C. We're going to write equals. We're going to write $5. Plus, we're going to go $2. And then what are we going to substitute? 9. Because the rides are 9 rides. Now we get $5 bed mass, right? Times first. So you're going to get $18. I should put a $sign here. We got 5 plus 18. The cost is, let's put C equals, the cost is going to be $23.